Hello students, welcome to the class. In the last class, we discussed about the gravitation synopsis, right? So today we will continue with the MCQ questions, multiple choice questions based on this topic. Okay, so the first question is the gravitational force between two objects does not depend on. Here the question is what? The gravitational force between the two objects, it does not depend on. The question is based on universal gravitational law. So what is our universal gravitational law? The formula is based on that we can understand the answer. So it is very simple. If you know the universal gravitational law for expression, directly you can write the answer. So the equation is F is equal to G into M1 into M2 divided by R square. So according to the equation, you can see here the force is depending on the product of the masses. Then the force is depending on the distance between the masses. Force is also dependent on the gravitational constant. Okay, so options what they have given, see, sum of the forces, product of the masses, sum of the masses, product of the masses, gravitational constant, distance between the masses. So according to the option, they asked, it does not depend on, so option A is the correct option. It does not depend on the sum of the masses, because here you can see it depends on the product of the masses. It depends on the product of the masses and distance and the gravitational constant. It does not depend on the sum of the masses. Okay, so option A is the correct option. Option A is the correct option here, right? Option A, you can take it as option A, that is sum of the masses. Let us see the next question. If M is divided into two parts, so you have a mass M which can be divided into two parts. One is written as x into M and one more is written as 1 minus x into M. For a given separation, the value of x for which the gravitational attraction between the two pieces becomes maximum is. Here mass, they have taken it as, instead of taking it as M1 and 2, it is divided into two parts and that is taken as x into M and 1 minus x into M. For the given separation of the value of x, for which the gravitational attraction between the two pieces becomes maximum. So when the gravitational force becomes maximum, let us see. That is, here the expression is what? The expression is given as F is equal to G into M1 into M2 divided by R square, which is equal to G into bracket. So here one mass is what? One mass is written as x into M and other mass is written as 1 minus x into M. So here parts M and 1 minus x into M it is. Okay, so therefore here it becomes first mass is M and the second mass is what? It is 1 minus x into M divided by what? Divided by it is R square, which is equal to G into M square. Inside the bracket it is 1 minus x whole divided by R square, whole divided by R square. So what they have asked you for maximum value of force. For maximum value of force, what we can write? For maximum value of force, we can write it as dF divided by dx is equal to 0. For maximum value of force, it can be written as dF by dx is equal to 0. Therefore, the equation becomes d divided by dx into bracket G M square into 1 minus x this divided by r square. So this is entirely in the bracket. This is equal to 0. I just substituted the value of f here, that is gm square divided by r square into bracket 1 minus x into bracket 1 minus x. Now this d by dx, see here, g and m are what? These are the constant. These are the what? Constant. Okay, so when these are the constant, so we can take it out of the integration sign, gm divided by r, right? So inside the bracket, it is left with 1 minus x, which is equal to 0, which is equal to 0. So we can differentiate this equation and then we can simplify and write it as, it becomes 1 minus 2x, which is equal to 0. Therefore, we can write it as x is equal to, see here it becomes 2x is equal to 1. Therefore, it becomes x is equal to 1 divided by 2. It becomes x is equal to 1 divided by 2. So what is the question? So when the mass m is divided into two parts, one is m and one more is 1 minus x into m. Here, for a given separation, the value of x for which the gravitational attraction between the two pieces becomes maximum. You can see that the value of x is 1, when it is 1 by 2, the two pieces becomes maximum. The gravitational force between two pieces becomes maximum, they will say here. So the correct option is option A is the correct option. Option A is the correct option here. Right? Next question. The mass of the moon is about 1.2% of the mass of the earth. Compared to the gravitational force the earth exerts on the moon, the gravitational force the moon exerts on earth is, see here, the moon is about 1.2% of the mass of the earth. Compared to the gravitational force the earth exerts on the moon, the gravitational force the moon exerts on earth is given by, first one it is same, second one it is smaller, third option it is greater, and fourth option it varies with its phase. So here, as we know that whatever the gravitational force is there between the two bodies, it will be what? Same. Why? Because whatever the force is there, what the force with which the earth gets attracted, with the same force the moon will also get attracted, irrespective of the masses. The mass of the moon is about 1.2% of the mass of the earth. Compared to the gravitational force the earth exerts on the moon, the gravitational force the moon exerts on the earth, it is same. Option A is the right option. Option A is the right option here. Next, fourth question. Four particles of masses m, 2m, 3m, and 4m are kept in sequence at the corners of a square of side A. At the corners of a side A, the magnitude of gravitational force acting on a particle of mass m, which is placed at the center of the square, will be. See here, what is the question? So you have four particles of masses m, 2m, 3m, and 4m. They are kept in a sequence at the corners of a square of side A. The magnitude of gravitational force acting on a particle of mass m, which is placed at the center of the square, will be. See how to do this one. So we need a calculation for a given question. Let us draw a diagram. The diagram is this is A, B, C, D, A, B, C, D. So here the masses are kept at this point. A point it is m, and at B point it is 2m, and at C point it is 3m, and at D point it is 4 into m. Okay. So each side, how much they have said? Each side is A, and it is A. The magnitude of gravitational force acting on a particle of mass m, which is placed at the center of the square will be. So when the particle is placed at the center of the square, what is the magnitude of the gravitational force we need to calculate? So from A point, we can take the force as from the A point, we can take the force as, here I'll write, it can be written as F A P, means at the center, I'll consider this point as P, then F BP, then F CP, then F D T. These are the four separation points. Okay, so if two particles of mass m are placed x distance apart, then force of attraction is given by. Okay, so what they have said, that is, if two particles of mass m are placed at the distance of x apart from the force of attraction, then the gravitational force is given by, that is, G m into m divided by x square, because I said the distance is x square. Then the expression becomes F net. Similarly, what we will do now, we will calculate the force at different point. See here, now according to the given question, at point P, we need to calculate the gravitational force. So first one, F P A is what? It is the force at point P due to the particle A. This is given by, it is G m into m divided by x square. Similarly, for the force at P due to B, it is given by G m, I'll take it as 2m, because at point B it is mass is m, then into m divided by x square, which is equal to 2g m square, okay, divided by, if we want we can simplify, or else we can keep it as it is also. Or see here, what else I can do, that is, 1 minute, that is this step. Instead of taking this step, see here, I can write it as this is equal to G 2, I'll write as it is, except 2, whatever the term is there, that is G m into m, he divided by x square, it is nothing but F. Okay, you can see here above equation which we have written. That is equation 1. According to equation 1, here it is there, right? That is 2F. Next, the force F at point C is equal to G into 3 into m into m divided by x square. This is equal to, so similarly, I can write it as 3F. And F P into D is equal to G into 4 into m divided by x square is equal to 4 into F. Therefore, the net force is given by, F net is equal to under square root of 2F whole square plus 2F whole square. So this is equal to, that is, 2 square is 4 plus 2 square is 4. 4 plus 4 is nothing but 8. So 8 can be written as 4 into 2. 4 into 2, the square root of 4 into 2 is nothing but 2 root 2. So 2 root 2, this is f square plus f square, right? So this can be written as F. Because it is 4f square 8f square it will be. That I have split and I have simplified it as it becomes 2 root 2 into f. It becomes 2 root 2 into f. Now substitute the value of f from equation 1. That is equal to 2 root 2. The value of f is how much it is? G m square divided by x value from the figure. So whatever the figure I have given you here, the right angle, this one, rectangle, whatever we have taken here. Okay, it is a square. Sorry, it is a square. So all the sides are, it is a. So I can apply the Pythagoras theorem and I can calculate the value of x here. The value of x is found to be, it is a divided by root 2 whole square. Root 2 whole square. So simplify this one. That is root 2 whole square is nothing but what? It is 2. So 2 into 2, it becomes 4 root 2 g into m square divided by a square. Here, that's just one step I have taken directly here, students. That is, what is that? A by root 2, how we are getting? That is, suppose this is a square. So this is the diagonal and all the sides, as I said, it is a. And suppose this is x. Here what happens? Whatever the distance is there, this we can calculate it as x distance can be calculated by using the Pythagoras theorem. So by Pythagoras theorem, we can calculate, then it is found to be a divided by root 2. So I have substituted and simplified. Okay, so this is how we can calculate the f net. So this one formula you remember, that is f net is equal to square root of f1 square plus f2 square. So f1 value is 2f whole square, f2 value is 2f whole square. So substitute and simplify. Right. So which is the correct option? Option C, that is 4 root 2 gm square divided by a square. Option C is the correct option here. Okay. So in second year also, similarly for what we can say that potential, net potential for right angle, square, for triangle and all we calculate. Same way we used this formula here. Okay. Option C is the correct option. Let us see the next question. Fifth question. If the radius of the earth were to shrink by 1%, its mass remaining the same, the acceleration due to gravity on the earth's surface would. So here we need to calculate, that is the acceleration due to gravity when the radius of the earth shrink by 1%. Its mass is remaining the same. So let us calculate this. What is the formula here? We know that the relation between G and R can be written as what? G is proportional to 1 divided by R square. G is proportional to 1 divided by R square. As the value of R decreases, as the value of R decreases, the value of G increases. As the value of R decreases, the value of G increases. Therefore, so percentage change in G is equal to 2 into bracket percentage change in R, percentage change in R, which is equal to 2 into 1%. That is nothing but what? 2%. Okay. So here what we did, that is if the radius of the earth was shrink by 1%, its mass remaining the same, the acceleration due to gravity. What happens to the acceleration due to gravity? So when they are saying it will shrink, means the radius decreases by 1%, means the acceleration due to gravity should increase by 2%. Okay, it should increase by 2%. Like that we can understand here, as the expression is G is inversely proportional to R square. So option C is the correct option here. That is, it increases by 2%. No need to simplify this, directly only we can answer, as we know that G is inversely proportional to square root of the square of the R square, right? Let us see the next question. The height of the point vertically above the Earth's surface. The height of the point vertically above the Earth's surface at which acceleration due to gravity becomes 1% of its value at the surface is. So what they are saying, the height of the point vertically above the Earth's surface at which acceleration due to gravity becomes, means the height at one point where the acceleration due to gravity is becoming 1% of its value at the surface is. The radius of the earth is given as r. So here we need to calculate the value of h. So simple it is. Why? Because they have given which formula we need to use. The height of the point means from the surface of the earth, it is at some point. So formula is, that is, acceleration due to gravity at height h is given by g dash is equal to g into bracket r divided by r plus h whole square. Therefore, so here gravity becomes 1%. That is nothing but g divided by 100 is equal to g into bracket r divided by r plus h whole square. So let us simplify this. G will get cancelled on both the side. So when you can cancel G on both the side, it becomes, that is, R by RH whole square is there. So I'll just take the square root here. If I take the square root, it becomes 1 by 10 is equal to R divided by R plus H. It becomes R divided by R plus H is equal to 1 divided by 10. So simplify this. What I can do here, I can cross multiply and I can write it as R plus H is equal to 10 into R. That is, H is equal to 10R minus R. So 10R minus R is what? It is 9R. 10R minus 9R is what? It is 9R. That is the value of H here. That is the value of H is equal to 9 into R. Okay. So option B is the correct option. Option B is the correct option here. Understood? So very simple sum. Only the thing is you need to understand how to substitute the value in the given sum. Next question. At surface of earth, weight of a person is 72 Newton. Then his weight at height r by 2 from surface of earth is. See here what it is given. At surface of the earth, the person weight is 72 Newton. Then his weight at r by 2 from the surface of the earth is. Means when the radius is r, its weight is 72 Newton. When the radius becomes r by 2, then what is the weight? Okay, so let us calculate this. So many students, what they will do, they will try to write 72 divided by half only, they will try to substitute. It is not so true. So how we need to do here is, that is, formula W dash is equal to W into bracket R divided by R plus H whole square. So this is equal to W into bracket R divided by, W is weight here, R divided by R plus, what they have said, R value, H value is what? Now here it is R divided by 2 whole square. So this is equal to W into bracket. So if I simplify this, R divided by R plus R by 2 whole square it is 2 divided by 3 whole square. That is equal to 2 by 3 whole square is how much? It is 4 divided by, 9 into W. 4 divided by 9 into W. So W value they have given. So how much the value they have given for W? W value is given as, that is W dash is equal to 4 by 9 into W weight is 72. So if I simplify this one, that is 3 3s are 3 2s are 6, 3 4s are 12, 3 1s are 3 8s are 8 4s are. So here it is 8 4s are 32 Newton. So which option is correct? That is option C is the correct option here. Option C is the correct option, right? Let us see the next question. Weight of a body of mass m decreases by 1%. Weight of a body of a mass of m decreases by 1% when it is raised to height h above the earth's surface. If the body is taken to the depth h in a mine, change in its weight is, so weight of a body of mass m is given, it decreases by 1% when it is raised to height h above the earth's surface. So when the body of mass is raised to the earth's surface, if the body is taken to a depth h in a mine, change in its weight is calculated as. See here how to do this one. So we can use the formula. That is delta GH is equal to H is equal to 2 into delta G into D. So here change in the weight of a body of mass m decreases by 1% when it is raised to a height. So here this is decreased by 1%. Therefore, it is 1 is equal to 2 into delta GD. That is equal to delta GD is equal to 1 by 2. So delta GD is equal to 1 by 2 is nothing but what? 0.5%. It is 0.5%. So here it decreases by what? 0.5%. Right? That is option B is the correct option. Option B is the correct option. So you can see in the expression GD is equal to GH it is. Therefore, when the value of GH decreases, the value of GD also decreases. But only the difference is the value here. There it is 1%, here it is 0.5%. Right? Then let us see the next question. The angular velocity of Earth with which it has to rotate so that acceleration due to gravity on 60-degree latitude becomes 0 is. So what they have given, the angular velocity of the earth with which it has to rotate so that acceleration due to gravity on 60-degree latitude becomes. So already we know that the acceleration due to gravity varies due to four concepts, that is due to the shape, due to the rotation, axis of rotation, due to the height, and due to the depth. So here what they have given, it is due to the rotation. The formula is what? It is g dash is equal to g minus omega square into r cos square theta. So this is equal to g minus omega square into r cos square theta. Value how much they have given? It is given as 60-degree, which is equal to, so this implies cos 60-degree. So cos 60 is 1 by 2. So 1 by 2 omega square, that is for cos square 60 it is, therefore it becomes 1 by 4. Therefore I can write it as omega square r divided by 4 is equal to g. Why? Because they have said g dash is becoming 0, therefore it becomes g is equal to omega square into r divided by 4. So I can simplify this for omega is equal to, therefore omega is equal to, it becomes 2 root of g divided by r. It is 2 root of g divided by r. But again, what quantity they have given? They have given radius of the earth, g value and r value. Both the values are also it is given. Therefore, further I can simplify it as, that is g is 10 and r is 6400. So 10 divided by 6400. If I take the square root and if I simplify this, the value becomes omega is equal to, I'll write omega is equal to, it is becoming 1 divided by 400 after taking square root and all the simplification. So 1 divided by 400 is nothing but what? It is 2.5, 10 raised to minus 3 radian per second. That is 2.5 into 10 raised to minus 3 radian per second. That is option A is the correct option. Option A is the correct option. Then next question. An infinite number of point masses, each equal to m, are placed at x is equal to 1, x is equal to 2, x is equal to 4, and x is equal to 8, so on. What is the total gravitational potential at x is equal to 0? So when the potential is 0, what is the value? Means the total potential we need to calculate when x is equal to 0. So let us calculate this. We need to use the gravitational potential formula. So here you can consider the mass which is at m, then the second mass is also at m. They said equal masses, okay. This is also m and here this is also m, so on, continue. Then the first mass is at a distance of 1 meter, the second mass is at a distance of 2 meters, the third mass is at a distance of 4 meter, and the fourth mass is at a distance of 8 meter. Okay, so what is the formula here? The formula is V is equal to minus into bracket Gm divided by R1 plus Gm divided by R2 plus Gm divided by R3 plus and so on. This is equal to minus G into M into bracket 1 divided by R1 is 1 plus 1 divided by R2 is 2 plus 1 divided by 4 plus 1 divided by 8, which is equal to minus Gm. So inside the bracket I can apply the formula. It becomes 1 divided by 1 minus 1 by 2. So the simplification is, it is V is equal to minus 2 into G into M. It is minus 2 Gm. So option B is the correct option here. Option B is the correct option. Let us see the next question. If mass of Earth is m, radius is r, and gravitational constant is g, then work done to take 1 kg mass from Earth's surface to infinity will be. So here work done we need to calculate when we are moving a mass from infinity to r distance of kg 1 of mass of 1 kg. Okay, so let us do this one. So final is infinity minus initial is ur, which is equal to, at infinity the potential is 0. We know this, minus into bracket minus of gm into m divided by r, which is equal to, this becomes gm divided by ry, because they have given the mass of the body as 1 kg. Therefore the equation, which one? There is equation B is the correct option. B, that is gm divided by r, is the right option. Okay. So very simple question. Only the thing is work done is equal to, we need to use uf minus ui formula, that we need to understand. And the potential at infinity is 0. This we should remember. Next question. A projectile is projected with velocity kve. Okay. Next, in vertically upward direction from the ground into the space. It is projected vertically upward with a into the space. Ve is escape velocity and k is less than 1. If air resistance is considered to be negligible, then the maximum height from the center of Earth to which it can go will be. Okay, so what they've asked you, if air resistance is considered to be negligible, then the maximum height from the center of Earth to which it can go will be. So let us calculate this. Here they have given that V is equal to K into VE, which is equal to K under root of, as it is a escape velocity, the expression is what? Root 2gr. Therefore, we also know that H is equal to what? V square divided by 2g. Right. So this is equal to, what is V value? V value is K into root 2gr. As it is V square, it becomes K square. It becomes K square 2 into G, R becomes R plus H. Okay. Therefore, we can write it as, H is equal to. So what I'll do, I'll simplify. For H means here, whatever the terms are there, only H term one side and other terms one side. So if I simplify this, I'll get it as H is equal to R into K square divided by 1 minus K square. Why? Because here R plus H is nearly equal to R. Therefore, I am taking it as R K square divided by 1 minus K square. So, height from the center is equal to what? R is equal to R plus H. Therefore, substitute the value. Now, here what I can do, that is R is equal to, from the center it becomes R plus H, which is equal to R plus H value is how much? It is R into K square divided by 1 minus k square. So if you simplify r plus r k square divided by 1 minus k square, this becomes r divided by 1 minus k square. That is r is equal to, r divided by 1 minus k square is the correct answer. That is option B. So option C here, that is it should be 1 minus, because option A and C, if you see it is written same, here it should be minus. Okay, so it is 1 minus k square. That is option C is the correct option, right? Then next, if the radius of earth reduces by 4% and density remains the same, then escape velocity will be. So what they are saying that is if the radius of the earth reduces by 4% and the density is remaining same, then escape velocity. See here we have escape velocity, VE is proportional to R root rho. Here we can write VE is proportional to what? R, as they have said, rho is density is constant. So if the radius reduces by 4%, the escape velocity also reduces by what? 4%, as they are proportional to each other. Therefore, the correct option is option C is the correct option. Both the values reduces by 4%, right? Next question. The maximum and minimum distance of a comet from the sun are m and m if its velocity when nearest to the sun is. So the minimum distance of a comet from the sun is that is sun are m and m. Then the nearest velocity is taken as 60 meter per second. What will be its velocity in meter per second when it is farthest? When it is farthest, we need to calculate. So according to the conservation of angular momentum, what we can write here? That is according to the law of conservation of momentum, we can write it as m v minimum into r maximum is equal to m v max into r minimum is equal to what? Constant. This is equal to what? Constant. Here it is v minimum is equal to v max into r minimum divided by r max. This is equal to, so v max it is given, it is 60 into r minimum value is 1.6 into 10 raised to 12 and r maximum is 8 into 10 raised to 12. Okay, so if I simplify this, the answer is 12 meter per second. The answer is 12 meter per second. That is for sun and the comet. The r value is given in the question itself. That only we have taken and we have simplified it. The correct answer is option A. Option A is the correct option. Let us see the next question. The distance of Neptune and Saturn from Sun are nearly 10 raised to 13 and 10 raised to 12 meters respectively. Assuming that they move in a circular orbits, their periodic times will be in the ratio. Their periodic times will be in the ratio. So we need to calculate the periodic ratio. We need to calculate the time period ratio. So let us calculate that. So according to the third law, we have T square is proportional to R cube. T square is proportional to R cube. So they have given Neptune and Saturn. I can take it as T of Neptune divided by T of Saturn whole square is equal to R of Neptune and R of Saturn whole cube. This is equal to. So R of Neptune is 10 raised to 13 divided by R of Saturn is 10 raised to 12. It's whole cube, right? According to our this one, that is our third law of Kepler. It can be written as 10 root 2. It can be written as 10 root 2 is the right option. That is option C is the correct option here. Option C is the correct option. And the next question is, a satellite is moving around the earth with speed. A satellite is moving around the earth with a speed v in a circular orbit of radius r. If the orbit radius is decreased by 1%, its speed will be. So how to calculate the orbital speed formula? Then calculation. Very simple sum. That is V naught is equal to under root of gm divided by r. This is equal to, as it is given that as a satellite, therefore r value becomes r plus h. It becomes r plus h. This is equal to gm can be written as what? It can be written as gr square divided by r plus h. It can be written as gr square divided by r plus h. Therefore, v is equal to under root of, or we can see from the equation, v is inversely proportional to root of r. V is inversely proportional to what? Root of r. Therefore, when the percentage change in v is, if the radius is decreased by 1%, then here it is written as 1 by 2 percentage change in r, that is equal to 1 by 2 into bracket 1%, that is the change in the radius. Therefore, 1 by 2 into 1 is how much? It is 0.5%. It is 0.5%. So here what happens when the value of r decreases, the v value increases by 0.5%. That is option B is the correct option here. Option B is the correct option. Next question. The escape velocity for a body projected vertically upwards from the surface of Earth is 11 km per second. If the body is projected at an angle of 45 degree with the vertical, the escape velocity will be. See here, the escape velocity of a body does not depend on the angle of projection from the Earth. Therefore, here what happens? It will be same. It does not depend on the angle here because our angle, this one, our escape velocity term does not contain any angle term in the equation. Therefore, it does not depend on the angle. Therefore, here the value is same, that is 11 km per second. 11 km per second. The next question. A particle of mass 10 gram is kept on the surface of a uniform sphere of mass 100 kg and radius is 10 centimeter. Find the work done to be done against the gravitational force between them to take the particle far away from the sphere. Okay, so here we can write, calculate the work done by integrating the equation. That is, we have a equation F is equal to G into M1 into M2 divided by R square. Therefore, the work done is equal to what? It is force into displacement. This is equal to force is how much? It is G M1 into M2 divided by R square into dr. Here it is integration of dw and the range is from 0 to w. This is equal to G M1 into M2 integration of, this is from R to infinity, and here it is dr divided by r square. So G M1 into M2, it is a constant, therefore taken out of the integration sign, therefore it becomes dr divided by r square. Now it is in the form of 1 divided by r square integration with respect to dr, and the range is 0, that is r to infinity. So the next step is the integration of dw will be w, that is equal to G M1 into M2 inside the bracket 1 by r square is minus 1 by r square, and the limit range is r to infinity. That is equal to, see here, G M1 into M2, upper limit is what? Infinity. 1 by infinity will be 0 minus. So 1 by r value, that is nothing but minus 1 by r square itself. Therefore, minus into minus it becomes plus. We can write it as G M1 into M2 divided by r square. Substitute the value. The value of G is how much? G value is 6.67 into 10 raised to minus 11. The value of G. The value of M1. One mass is given as 10 gram. One mass is given as 100 kg. Substitute the value of masses divided by R is 10 centimeter. So 10 centimeter to meter, it is 10 into 10 raised to minus 2. So substitute in terms of meter, simplify. So after simplification, the answer is found to be option B. So you just substitute and simplify the term here, because whatever the question it is given, means the values are given already, directly you can substitute in the formula. Right, option B is the correct option here. Then next, the change in the value of G at a height h, above the surface of the earth is the same as at a depth d below the surface of the earth. When d and h are much smaller than the radius of earth, then which of the following is correct? So just now we used one formula, same formula, the relation between G and D, that is h and D. That is delta GH is equal to delta GD 2GH divided by R is equal to G into D divided by, sorry, it is in the suffix GD divided by R. So if I simplify this, R will get cancelled. Therefore, I can write it as 2H is equal to D. So it is not in the suffix, that is G will get cancelled. Therefore, you will get it as 2H is equal to D. That is option A is the correct option. Option A is the correct option here. Right? Means the D and H, when they are in this ratio, then we can satisfy the given condition. Okay. Then the last question for today's class is, if suddenly the gravitational force of attraction between Earth and a satellite revolving around it becomes zero, then the satellite will. So what happens here? What they have said, the gravitational force of attraction between the Earth and the satellite becomes zero. So when the gravitational force becomes zero, the centripetal and centrifugal forces also disappears. Okay, so what they have given options: continue to move in its orbit, move tangentially, become stationary, move towards the Earth. Here what happens, as the centripetal and centrifugal force also disappears, the satellite has the tangential velocity and it will move in a straight line. It will move in a straight line. Means here what happens? A tangentially motion takes place. So you have studied already, that is a circular motion. So in circular motion, we come across this concept. So whenever any object is moving in a circular path, if that is braked, here what happens, the along the tangent the body will move, along the tangent the body will move, right? So today we discussed based on Kepler's laws and based on the universal gravitational constant, the numericals. In the next class we will continue a few more numericals based on satellite and all. Okay, thank you students.